So today's notes are a little bit of review about how matter changes, and we're going to take it a few steps further once we review chemical and physical changes and discuss how chemical reactions take place. So just to review, a physical change is a change that alters the appearance of a substance. So it changes what the substance looks like, but it doesn't make the material itself into a new substance. So some examples that you have to write down are phase changes. So this means like melting or freezing or boiling, tearing paper, crushing a can. What I'd like you to do is think of two more and fill in the other two blanks. And you are welcome to use your notes from a couple of weeks ago when we were discussing physical changes. Then chemical changes is the other type of change in matter. And this is when we get a new substance altogether. So we have the same type of matter, but it's been kind of rearranged so it looks completely different, and we can tell that based on some of those characteristics, like we have bubbling, we have a change in color, we have a change in temperature. Those are all signs that chemical changes took place. And so a few examples here are photosynthesis, burning, and tarnishing. Those three things change the matter to the point where we can't really get the original substance back without doing another chemical reaction if necessary. And just like with physical changes, I want you to try to think of two more, either using your notes or maybe you remember on your own and you can think of two on your own, but we'll discuss those in class. So chemical reactions are processes where the substance undergo chemical changes. So in this picture on the left, I know a lot of people ask me what chemicals those are. Honestly, I can't remember. Somebody else made this PowerPoint for me a long time ago, and I don't remember what the chemicals are, but you can tell that they're two clear substances that are being poured together, and then we end up with this yellow, solid-looking, powdery substance. So that's an example of a chemical change taking place. The one on the right is showing oxygen and hydrogen coming together as gases, and they create water, which is a completely different type of substance. So when we are putting these substances together, no matter how they change, the total mass, the total amount of matter that we're dealing with stays the same. So we either have a little cartoon that describes that. But this idea is called the law of conservation of matter. The word conservation is talking about we're conserving the amount of matter. We're not losing any matter in the process. It hasn't gone missing. We haven't brought in any matter in the process of a chemical change. We use whatever we have, and all of it is used up in some way. So a short, easy way to show that a chemical reaction has taken place is by using chemical equations. And instead of using long words and writing out like an entire sentence, we use symbols to represent the elements or the compounds that are involved in the chemical equation. So to satisfy the law of conservation of matter, so to show that we have the same amount of matter at the beginning of the change as at the end, when we write this out in a chemical equation, we have to be sure that we balance each side. And so this equation right here is not balanced as it is. What we need to do is add coefficients to the element or to the compound, and that tells me I'm bringing in more of that same substance. And we're not changing anything about the substance itself, but I'm just bringing in more copies of it until we have the same amount of each element on both sides of this arrow. So as we're going through a few examples of this, we need to understand some vocabulary that we probably haven't heard before. So reactants are the materials at the beginning of a reaction. These are kind of like the ingredients that you put together, like when you're making a cake or you have some kind of recipe you're trying to follow. The ingredients that you start out with would be the reactants. The products are the new materials at the end of an equation. So what you're hoping to make through your recipe, the end result would be the product. When we're writing this out in a chemical equation, you have the arrow. And so I told you in class that when we're reading from left to right, you would read the arrow with the word yields. And this simply means it makes, or we end up with this next thing. The plus signs indicate that there are more than one reactant or more than one product. So there's more than one ingredient at the beginning, or there's more than one product at the very end that you're achieving. So we have the coefficients also pointed out in this diagram. The coefficients are the big numbers, and hopefully you remember the smaller numbers are the subscripts. That tells us how many of each individual element are in the formula. So here are some rules that we need to follow when we balance equations. And on the second video, I'm going to walk you through the process of balancing several equations in your notes. And we're going to follow the steps of this process every time. So if you're writing down an equation on a separate sheet of paper, like say you're taking the test and there's not enough space for you to do it, you want to make sure first and foremost that you copy the equation down exactly as you see it on the problem. And from there, you're going to count the number of atoms of each element on each side of the equation. One thing that you need to remember is when you're starting to balance the equation and bring in more atoms, you never, ever, ever change, remove, or add the subscripts. So the little number that is behind the element or in the middle of the formula for the compound, that has to stay the same because that tells us the ratio of all the atoms that are making that compound together. We don't want to change that because that would change the identity of the substance. What we want to change is how much of that substance we have. So it's kind of like doubling a recipe. Add or change coefficients is what we want to keep in mind. So all we're doing is bringing in the bigger numbers that go at the front of the formula or the front of the element. And so that leads us to our last rule. We always put those coefficients in the front. We never kind of squeeze them in the middle of the formula to fit with just one element. If we are dealing with the compound, we have to bring in both of the elements. And we'll talk about that as we go through the examples. So this is it for the first video. We've got all the information. Now what you need to do is watch the second video and go through the process of balancing equations with me and write everything out, follow along, and if you are confused, please make sure you write down questions or make a note to yourself about what confuses you, what specific part is messing you up, and that way we can identify those problems in class and it will help me a whole lot in being able to make you understand it better. So good luck with it and let me know what you think.